In this session, what we are going to do is we are going to use something called as create block design, and we'll be uh, using it to connect our module to various IPs that are available via Xilinx. Okay, and we will try to generate the file that will be dumped on our FPGA. Okay, and we will be using something called as ILA and VIO. So those are two different IPs. Those are available through Xilinx. Okay. So click create block design and just give your block design some name. So let's say I'm calling it block underscore design. Okay. So you have this workspace available to you. You can just yeah. So we will first add our module that is HA. You can add it. So just by right click and see this option add module and we'll get this. Okay. And I need to add the VIO IP. Okay. And what does this VIO IP do? So basically, I have two inputs A and B, and I don't want to use a test bench to give some value to A and B. But what I want to do is when I have connected my FPG, I want to uh, give input not by the buttons that are available on the board, but I want to toggle it in real time on software, right? So for that, I'm using this VIO, and I need two inputs, A and B, but the probe has only one output. So I'll just double click this and output probe count. I'll keep it. Okay. Now I'll connect one. You just need to click on one and just drag it. It will get connected. Okay. Now I have sum and cout. So any of the ports, you can make it external by just clicking it and right click, make external. So it will create that port as external. But and in the constraint file, what you can do is you can assign this port to some particular pin name available on the board. Okay. But for this experiment, I'm not going to keep it external, but I'm going to use something called as system ILA. So I right click, add IP, and type system ILA. Okay. And I just okay. So I'll need two outputs. So I'll just double click this. Monitor type, I'll change it to native. Number of probes, I'll set it to click on OK. Then C out, I'll connect to probe 1, sum to probe 0. Once it is done, so what you can do is you can just run connection automation and it will add the clock wizards. So you can see that these IPs, they need a clock. Okay. So the clock wizard will take care of that. So just click on run connection automation. Okay. So the first automation says connecting the clocks present here. Okay. So it added the clock wizard on its own. But I don't need two clock wizards. I'll be fine with one. I'll just delete one and this clock I'll connect it. Okay. Still, we have run connection automation available with us. So I'll just click that. Okay. So, okay. Okay. So basically, I have a system clock as external and a reset pin that is available to me as external. So I'll just regenerate this layout to make it look uh, better. And then I'll click on validate design. Okay. So the validation is successful and there are no errors or critical warnings. Click on OK. Okay. And once that is done, so this block diagram, I need to create a wrapper for it. So right click on this, click on create HDL wrapper. Okay. And let Vivado manage wrapper and auto upgrade. Click on OK. So now you can see that it has created something called as block underscore design underscore wrapper dot b. Okay. So this is basically the complete wrapper and it is set as the top module. You can see that small pyramid. Okay. Once that is done, so you can click on run implementation directly. Basically, you need to run synthesis and implementation. But if you click on run implementation, it will ask you, do you want to run synthesis first? And select yes there. Okay. And the synthesis and implementation process, it starts. Okay. We'll wait for some time. Okay. So once the implementation is complete, so click on open implemented design. Press OK. Go to IO ports. So here, choose scalar ports as H16. Okay. And LVC mask 23. This is fine. Okay. Similarly, go to the other scalar port that we have, that is the reset RTL. Okay. So I'll choose D19. So once this is done, you just save the constraint file, clicking on save constraint. Okay. So I'll just say constraint and give the file name as constraints3. Click on OK. Okay. Once that is done, you can just click on sources and have a look at the constraint file. Okay. So here you can see that the constraint file has D19 reset RTL, but the sys clock at 16 is not visible. So we need to again open this. Let me write at 16 again. Let me just save the constraint file again. Okay. Now you can see that we have this H16 also included in the constraint file. So this is very important. You need to check that after you have saved it, whether you are able to get whatever pins you have chosen here, whatever IO ports you have chosen here, those are loaded here. Okay. So the rest of the part is because of the IL, so uh, that is added automatically. But yeah, you need to ensure that these things, whatever you have chosen, are uh, present in the constraint file or not. Because otherwise, when you are actually running it on the FPGA, then it is going to give you some issues. Okay. So once this is done, so you can see that the synthesis and implementation is out of date, right? So we need to do the synthesis and implementation again. Uh, and later we need to generate the bitstream. So what I'll do is I'll just click on generate bitstream directly and it will ask me to do the synthesis and implementation first. So it will do it automatically. I'll just click on yes. Okay. And we'll wait till the synthesis and implementation is completed. And it will give us the final uh, bitstream file that has to be loaded on the FPG. Okay, so let's wait till the complete bitstream generation is over. Okay, so once the write bitstream is complete, so you can see you'll get a message like this bitstream generation successfully completed. Okay, and if you have your board connected and ready, then you can just click on Open Hardware Manager and press OK. Or in my case, I haven't connected the board yet, so I'll just click on OK. And you can see the reports, yeah, the timing, power, and other reports that are available. Okay, and when you connect the board, you can just click on Open Hardware Manager. Okay, and yeah, that we will cover in the next session. Okay, okay. So one more thing that I wanted to cover here. So here, Xilinx provides an IP called as VRAM. Okay, uh, to add that into your block design, you can just click on Add IP. It is called as Block Memory Generator. Okay, so double click that, and just double click on this thing, and there are two modes available. So let's say I want to use the standalone mode. Okay, so here I have an option to initialize the VRAM. So we initialize it using a file called as COE file. So click on load init file and browse, and just select the COE file that you have written, and click on open, and that will load the COE file. Okay, using this, you can just initialize your VRAM. Okay, and this VRAM you can connect it to your module to provide data to your module. Okay, so yeah, so that's all we have for this session.